In this lesson, we get to use more of that list of steps for factoring. We skipped steps 2 and 3 in most of the work that we did in lesson 4 because we already had 4 terms. So we could make a binomial plus a binomial. But today we're going to start out with 3 terms each time, and so we're going to need steps 2 and 3 today to create 4 terms. That way we will be able to group and make a sum for step 4. So here's an example of what we mean. Look at number 1. Number 1 says factor, and it gives us 6n squared minus 23n plus 7. In order to do a problem like this, we first look for a big GCF. Well, 6, 23, and 7, they don't have any common factors, and there aren't any variables that they have in common. So this is, we can skip step 1, the big GCF, because there isn't that one. So here's where solve the puzzle comes in. You know those puzzles that we've been doing in class where we ask ourselves what multiplies to make this and adds to make that? Well, we've been getting ourselves ready for this point. So the question is, what are we doing the puzzle on? Because before it was just random numbers, and now there's actually a purpose. So the way we figure out what multiplies to make is we look at the first term and the last term. We multiply them together. So 6n squared and 7n multiply to make 42n squared. So we want to know what multiplies together to make 42n squared. And then the adds to make, well, that's always going to be the middle term, the negative 23n. So we're looking for things that multiply together to make 42n squared and add together to make negative 23n. Well, 42 has some factors. Not sure which one's going to work. If I think of maybe 6n and 7n, that gives me 13n. So I can see that that doesn't work. My sign's wrong, so it looks like I'm going to need 2 negative numbers. I also need bigger things. So let's see. 42 is also divisible by 21. So a negative 21n times a negative 2n would give me 42n squared. If I add those together, I get the negative 23n I'm looking for. So that seems like the pair I want. So that's step 2, solve the puzzle. So that was step 2, solve the puzzle. So now we're doing step 3, split the middle term. So we're going to rewrite the problem. The 6n squared is going to stay, and so is the 7, because those aren't the middle terms. But that negative 23n is going to get split up into those 2 pieces that we just identified, negative 21n minus 2n. That's step 3, split the middle term. So now we're back in a situation like the notes that we were doing in lesson 4. We're ready to group to create a sum. So we group the first 2 terms together, 6n squared minus 21n, and to that we add the last 2 terms grouped, negative 2n plus 7. We can take out the GCFs. So as we look at 6n squared and negative 21n, we can see that they're both divisible by 3 and they both contain an n. We would have to multiply that 3n by a 2n, and we'd have to multiply the other 3n by a negative 7. So that's going to let us factor out the 3n that they have in common and leave the 2n minus 7 in parentheses. And when we look at the other 2 terms, negative 2n and positive 7, that first term includes a negative, so we're going to say that they have a negative 1 in common. I know it doesn't feel like they have it in common because the second term is positive, but if our first term is negative, we're always going to pull out a negative 1. So negative 1 would have to be multiplied by 2n, and negative 1 would have to be multiplied by negative 7 to get back to the original numbers. So I've got a negative 1 and a 2n minus 7. Notice that gives us a binomial GCF of 2n minus 7 that I can factor out, leaving behind the other binomial of 3n minus 1. And that is the binomial factorization of your trinomial. You've done the process. So let's try this process a couple more times. First, we're going to look for a big GCF. So in number 2, notice that all those numbers are even. So that would suggest that we could pull out a 2 from everything. So we've got v squared minus 6v plus 5. From there, we're going to have to solve the puzzle. Remember, we're looking for things that multiply to make 5v squared. We're taking the first term and the last term and multiplying them together. And I need those same 2 things to add to make negative 6v. Well, when I'm seeing that I need to add to make a negative, it suggests to me I'm going to need two negative terms. So there aren't a whole lot of things to multiply to make 5, like 1 and 5. So I might try a negative 1v and a negative 5v. I can see that those multiply to make positive v squared. And when I add them together, I do get a negative 6v. So that was my only option, and luckily it worked. So I can now split the middle term, step 3. So v squared and plus 5 still begin and end my term. But that negative 6v splits into two terms, negative 1v and negative 5v. Now I can create the sum inside the big brackets. So v squared minus 1v will be one binomial, and negative 5v plus 5 will be the other binomial. So now I'm looking for GCFs like we've done in the past. If I've got v squared and negative v, they have a v in common. The top needs to be multiplied by another v, and the bottom needs to be multiplied by a negative 1. So I can factor out the v that they share and leave behind a binomial of v minus 1. Then I look at negative 5v and positive 5. Remember, if the first term is negative, you always take a negative, but this time instead of taking negative 1, we can actually take negative 5. The top would need to be multiplied by a v and the bottom by a negative 1. So I factor out the negative 5 that they have in common, and I leave in a v minus 1. Well, that's going to be the end of my big brackets because I still have the 2 from the outside. I have the v minus 1 that they had in common, and they leave behind a v minus 5. That's the full factorization of that trinomial. Now, number 3, when you look at this, you're thinking, wait, that's not a trinomial. True story, it's not a trinomial. Okay, let's start by looking for a big GCF. Well, x squared and negative 100, they're not divisible by anything, so I can't factor out a big GCF. Now, normally I want to solve the puzzle to create, to split the middle term, but there aren't even 3 terms yet. So we're going to create 3 terms. Well, we're going to keep the x squared, and we're going to keep the negative 100, but in the middle, I'm going to write a plus 0x. This makes it look like a normal trinomial, right? It goes in standard form. The first term has an x squared, the second term has just an x, and the third term doesn't have any variable at all. And adding 0x doesn't actually change the value at all because it's the same as adding 0. It doesn't change what's going on here. But now I can see the 3 parts, and I'll be able to split the middle term. So I'm looking for 2 things that multiply to make negative 100x squared. That's kind of a big number. And adds to make 0x. So I've got to think, what can multiply to make a negative 100 and add to make 0? Well, the first thing that springs to mind for 100 is 10 and 10. But one of these would need to be negative, and one of them would need to be positive in order to get a negative 100x. So if I then add those things together, look at that. That gives me 0x. So those are the 2 middle terms. So I'm going to start by splitting the middle term. So I have x squared minus 10x plus 10x minus 100. Notice the first and last terms didn't change, and the middle term split into those 2 terms. So we've done steps 1, 2, and 3 at this point. All right, now step 4 is to create that sum. So we're going to have x squared minus 10x plus 10x minus 100. Now we look for the GCFs on each binomial. So x squared and negative 10x each contain an x. The top would need another x, and the bottom would need a negative 10. So we can factor out the x that they share and leave behind an x minus 10. Well, 10x minus 100, they have a 10 in common. The top needs an x, and the bottom needs a negative 10. So we'll factor out the 10 that they have in common and leave behind an x minus 10. Notice they have a common binomial. They're both containing an x minus 10. So we'll factor out the x minus 10 that they have in common and leave behind an x plus 10. And there's your binomial factors for that original little binomial that we started with.